So as you can see here, the Takura console allows you to browse through content on the web, and we can choose from a number of different collections that store different types of information. We can then choose a particular class with which we want to associate this information. Now, if we turn on our roles as a data harvester, we can then go and add a new element, a new polity in this case. We're going to add this, and the ID we will call Latium test, and we can add a label to it and some comment that goes along with this data point. After this, we can add any number of properties, and there are a large number of properties that are associated with a polity. Each property can be associated with some class, or some superclass, or some subclass. Here we're adding irrigation systems, and if you look through, you see that there is no irrigation system variable present in the current Seshat codebook or wiki. We can also add other properties. There's a lot of properties. We have alternative names. This is listed in the wiki as Lazio. We can add a UTM zone, which is also present there. And we can add a polity territory. And here you see a map comes up for us, and we can zoom in, and using the map on the wiki page here as a template, but it could be any web page, we can go ahead and define the polity territory. Carefully. Okay, and this is actually going to define a polity, or a polygon for this polity, and this polygon will be stored in the triple store and can be searched, and from that we can derive other information like the territory in square kilometers, or whether it has overlap, or it can be used for geographical search. Now we can go back and we can see that this is now in the database, and we can ask for the various properties of this data point in the database for Latium test, and we see that it has irrigation systems unknown, 33T as the UTM zone, and Lazio as alternative names, and we can see here that it has stored the polygon for the polity that defines its territory.
Our last showcase is the Schema Manager. Here we select the Sesha dataset again and go to our Sesha ontology. We select the polity class and immediately see a description of the class and click on the Edit button. This allows us to edit the label, type and class description of the polity class. We cancel this for now and select the property polity territory. After clicking Edit, we are allowed to define and modify basic infos about the property, as well as what it relates to. We choose a political authority as a domain and the boxed literal coordinate polygon as range. This means that a political authority will have a polygon which defines its territory. After some thought, we decide to create a new property about drinking water supply systems. So we click the Add button. On the right, adjust the label and set a property ID. We set epistemic state as the range and test if our inputs are valid. Shockingly, this shows us an error in the lower left part of our modeling area. It warns us that our property ID has invalid characters. So we remove the prankster from the ID field and test again. This time we are scolded for leaving out the description field. So we add a witty description, set political authority as domain, and test again. Great success! Everything seems to be fine now. So we can add the property to our model, and an autocomplete powered search in the property field proves that we have been successful. To browse our model, we switch to data browser mode, select the polity and our brand new property, and set the value to unknown, since it is not yet part of the wiki.
This section showcases the ontology management service. Here we are adding a new ontology. This is the vocabulary of interlinked datasets, or void vocabulary. Let's see, we enter a prefix, title, a namespace, and the contents of the ID of the ontology, its type. We can then test the ontology, which shows a number of errors. These errors describe various kinds of errors created or identified by the Takura Quality Service. We can then add the ontology to the Takura Ontology Management Service. It will then be displayed in the Ontology Manager. Now we can see the ontology after it has been added to the Ontology Management Service. We can view the ontology in a variety of different formats, such as internal JSON storage, JSON LD, TurtleTerse RDF, and many others. We can view ontology metadata, such as the title and namespace, in the Metadata tab. We can view the history of updates which have been made to this ontology. We can see the details of each of these changes by clicking on them. We can view a history of applied updates to the ontology in the Updates tab. The Analysis tab allows us to perform quality analysis on the ontology. Here we can see warnings and errors which have been detected in the ontology. We can view summary information by hovering over these boxes. In addition, we can click on them to see these in greater detail. This tab shows a variety of errors which the Data Quality Service has detected. This tab shows the tests which are currently being run on the ontology. This tab shows the ontologies which are imported into the void ontology in order to support it. The Dependencies section shows the external links and dependencies which the ontology depends on. Structural links shows the class and property relationships included in the ontology. The dependencies shows the ontologies which are referenced in the ontology. Schema links shows ontologies which contain properties that are used in the ontology. The Vocabulary Utilization tab shows how the ontology is used. It provides a breakdown of the subjects, predicates, and values of the various namespaces within the ontology. In addition, it shows the varying types of predicates which are imported by the ontology.